So continuation of the previous class, that is calculation of range and quartile deviation for a frequency distribution. So we have already found out the value of Q1 and Q3, because for quartile deviation the formula is Q3 minus Q1 divided by 2. So you need to know the value of Q3 and Q1 to find out quartile deviation. So we have already found out the value of Q1 by the formula. Formula is given as it is here. So how do we find out this value of Q1 is this one. So first you find out the size of the item. So you have to first find out the size of this Q1, and likewise even for Q3 you find out the size of Q1 and Q3. So to find out this Q1 size, what you do is, formula is given here, n by 4. So n by 4, when we calculate it we get 10. So size of Q1 will be the 10th value. Where is 10th value? The class containing the 10th value is 10 to 20. And in this class interval you can find out the value of L. L is the lower limit of the class interval, that is 10. What is CF? CF is the cumulative frequency, or the frequency. So C is nothing but the value of cumulative frequency, preceding. This is the, this 10, 20 is the quartile classes. 10 to 20 is the quartile classes. So CF is nothing but the value, or the cumulative frequency value preceding this class interval. So preceding class interval is 5. So we get here CF as 5. And what is F? F is the frequency corresponding to this class interval. And lastly, what is I? I is the class interval, the difference between the lower limit and the upper limit, or the class interval of the quartile classes interval. That is 20 minus 10 is 10. So I is 10. So that is how we find out the value of all the formula. So substituting all these values we get 16.25. Likewise even for Q3, to find out the size of the Q3, 3n divided by 4, and we found out that it is the 30th value. And it is same with the process of the Q1. So substituting all these values, we have the value of Q3 as 42.87. At last we have quartile deviation, that is Q3 minus Q1, which is divided by 2. So Q3 is this one, Q1 is this one, divided by 2, and the quartile deviation at last we have 13.31. So that is how you calculate the quartile deviation for the frequency distribution. So for an individual, or an discrete series, Q1 size can be found out by n plus 1 by 4 value. So this is the case of individual or discrete series. But in a continuous distribution, it is the size of, so Q1 would be equal to n by 4 value. So this is in case of continuous series. So similarly even for Q3 and median also, n is used in place of n plus 1. So n is used in place of n plus 1 even for Q3 and median when it comes to continuous series. So the next topic that we are going to discuss is measures of dispersion from average. So from the average we are measuring the dispersion. So we have discussed that dispersion is the extent to which values differ from their averages. So dispersion, as we have defined, it is the extent to which, the values, the different values differ from their averages. So that is dispersion. So range and quartile deviation, they are not useful in measuring how far the values are. So range and quartile is not usually used in measuring this, how far the values are from their averages. What is the difference from how much is the value different from the averages is not calculated through range and quartile. Yet, by calculating the spread of values, they do give a good idea about dispersion. So two measures which are based upon deviation from the values from their average are mean deviation and standard deviation. So how much the values differ from their averages is measured particularly by two measures, that is mean deviation and standard deviation, that we are going to discuss. So since the average mean the central value, so the central value, so some deviations are positive, so some side it will be positive, some side it will be a negative. So if these are added, if these both are added together, then the sum will not reveal anything. In fact, the sum of deviations from arithmetic mean is always 0. That is why it is said that the average, which is containing both negative and positive side, when you sum up together, then they will not show anything, because the sum of deviations from arithmetic mean is always 0. So let's look at this one example. So let us look at this set A and set B. So you can see that values in set B, they are much more, or they are farther, they are spread more wide from the average than the set A. So set B, the values in set B are farther from the averages and hence more dispersed than the values containing in set A. So average would mean the middle one, both will have negative and positive. So more dispersed, you can see that in set B they are more dispersed from the average, and here it is less dispersed from their average. So mean deviation tries to overcome the problem by ignoring the signs of deviation. So it considers all deviations positive. So as we have mentioned, there are both positive and negative side when we talk about the average. So what mean deviation tries to overcome is, they try to do away with this problem by considering that all deviations are positive. So for standard deviation, the deviation are first squared and averaged, and then square root of the average is found. So we shall discuss them in detail, what is mean deviation, with the help of example. So suppose a college is proposed for students of 5 towns. So there are 5 towns where the number of students are staying here. So different 5 towns are there where students are staying, and then a college is proposed for these students. So town A, B, C, D, E, there are 5 towns. So this 5 towns is given, or it is situated near the road in this order: A, B, C, D, E. So distance from town A and number of students are given below here. So distance from town A is given here in kilometers, and the number of students is also given here. So calculation of mean deviation from arithmetic mean for ungrouped data can be calculated from this example. So firstly, we have direct method, And then we will also do the mean deviation from the median for ungrouped data, and then mean deviation from mean for continuous distribution. But firstly, let us discuss about the direct method when it comes to calculation of mean deviation from arithmetic mean for ungrouped data. So be careful, calculation of mean deviation from arithmetic mean. So again, let me repeat, we are discussing for ungrouped data, that is mean deviation from arithmetic mean for ungrouped data. And secondly, we will discuss for ungrouped data mean deviation from median. So first it is mean deviation from arithmetic mean. Secondly, it is mean deviation from the median. So for mean deviation from arithmetic mean for ungrouped data, the formula is given here. So we can calculate this mean deviation from arithmetic mean by summation of d divided by n. So first up, you have to find out this summation or arithmetic mean. First, you find out arithmetic mean, that is the first step. And secondly, you find out d. And after finding out that, you substitute the formula, or you substitute the values in the formula. So what is our arithmetic mean? Arithmetic mean is summation of x by n. Where is our x? Arithmetic mean is summation x by n. So here our summation x is 30. When you add up all this, it is 30. So 30 by 1, 2, 3, 4, 5. Our number of observations n. So it is 6. So 5. Here it is 5. So 6 is our arithmetic mean. And how do we find out d? Okay, we are calculating from the for the different data, that's why. But now actually we are going to calculate the mean deviation of the following values. So the question is asking to calculate the mean values or mean deviation of the following values. So as I have said, the formula for the mean deviation from arithmetic mean is md summation by n. So for that, you have to find out arithmetic mean. You have to find out d, and n is 1, 2, 3, 4, 5. There are 5 observations. So we have found out that arithmetic mean is summation x divided by n. So summation x, when you add up all this, you will get 30 and 5. So am is 6. Yeah. So you form a table like this. This is the x. And how do we find out this d? We find out d by subtracting arithmetic mean, or this number 6, from x. So 2 minus 6, 4 minus 6, 7 minus 6, 8 minus 6, 9 minus 6 will give us 4, 2, 1, 2, 3. So that is how we find out d. So now you can use this formula. So md is summation d 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 by number of observation is 5. So this will give us 2.4. So that is the answer. So that is how you find out mean deviation from arithmetic mean. So let us find out the mean deviation from median. Now it is median, it is not arithmetic mean for ungrouped data. So calculation of mean deviation from median for ungrouped data. So we will use the same, same number or same question that is given before. So question is, we have to find out mean deviation from median for the following datas. That is 2, 4, 7, 8 and 9. So first, since it is from mean deviation from median, what you have to find out is calculate the median value, which is 7. So first calculate the median. So median means the middle value here. So median is 7 here. After finding out median, you find out D, and D can be found out by, as given here, 2 minus median is 7, then 4 minus 7, 7 minus 7, 8 minus 7, 9 minus 7. So D will be minus 5, and it is said before that we have to ignore the signs when we talk about mean deviation. We ignore the sign. So since it is minus 5, we are not going to consider this sign. So here 3, 0, here it is 1 and 2. That is how we find out D. Now you can use the formula, that is mean deviation from median is the summation D by n. And now summation D here is 5, 6, 7, 8, 9, 10, 11. So 11 by number of observation is 1, 2, 3, 4, 5. So 11 divided by 5 is 2.2. Remember, this is for median. When it talk about arithmetic mean, this sign will come here. Median, it is given here. So earlier, though there is the same formula, but we have got different value. Earlier it was 12, that is why we got different values, and here we will get different value. Though the sign of the symbol for the formula is the same, the value will be different when it comes to median and arithmetic mean. So that is for ungrouped data, calculation of mean deviation from median. Earlier it was mean deviation from arithmetic mean for ungrouped data.